Hello, good morning everyone. This is Dr. JUDE, Assistant Professor from PG and Research Department of Physics, St. Joseph's College of Arts and Science, Cuddalore. Today we are going to discuss about the defects in crystal. So, as we already know what is a crystal, it is defined as a material which is in the ordered in a perfect pattern in a repetitive manner. As we know, the crystals is a periodic arrangement of atoms in a similar fashion. So usually if we speak about the crystals, definitely there will be a number of defects. There are classification of the defects in accordance with its nature, and it is very obvious for us if we found a defect in it, the impact of the macroscopic properties of the materials definitely affect due to these defects. Let me discuss about these defects. These defects are classification in terms of dimensionality. First one is zero dimensional defects, it termed as point defects. The next one is one dimensional line defects, two dimensional both surface and interface defects, and in 3D it is volume defects. So the general classifications are vacancy, interstitial, Frankel, Schottky, edge dislocations, grain and twin boundaries, inclusion voids, crack stacking faults, and dislocations like screw. It has both positive and negative dislocations too. This is the major classification of defects in crystalline solid. These are the major four classification called as point, line, surface, and volume defects. The point defects are further classified as vacancy, interstitial, substitutional, Schottky, and Frankel, and whereas in line defect it is classified as edge dislocation and screw dislocations. In surface defects we have grain boundaries and twin boundaries, and finally the three-dimensional volume defects, it is classified as voids, cracks, inclusions, and precipitate. In point defects, as we see, the diagram gives the overall picture of the defects in the crystal, such as vacancy, interstitial impurity, self-interstitial, substitutional impurity, and Frankel defect. These are classified, comes under the category of point defects, or irregularities or deviations from ideal arrangement around a point or an atom in a crystalline substance. It is a zero-dimensional defect. As we know, it has its own nature, both interstitial and substitutional. These are classified under point. Here you can see the vacancy defect. The right side is the perfect crystal, and the left side, which is the vacancy of a point defect, it is denoted. It is obvious for us to see a vacancy position, which these atoms are arranged in a regular manner. The atom is missing in its position, and this vacancy is termed as vacancy defect. Atom missing from its atomic sites. Atom is missing in its regular position. Due to this defect, there may be a decrease in the density of the substance. Obviously, it affects the mechanical strength of the crystal or the material. The number of vacancy defects, it completely depends upon the temperature. One of the parameters is the temperature too. If the temperature rises, there may be evaporation, so obviously there is a missing of an atom in its position, and it is termed as vacancy defect. The next one is interstitial defect. As we see in the diagram, the right side contains interstitial atom. It means a foreign atom is placed inside the positioned atoms, which is already in a regular pattern. The interstitial atom just penetrates and or fixes into its abnormal position in between these crystals. Addition of an extra atom within the crystal structure, this defect decreases the density of the substance. Surely it will cause distortion. So as we know, interstitial, the impurity atom is present within these regularly patterned atoms. The next one is Schottky defect. As we see in the diagram, there is a pair of atoms, both cation and anion. or missing in its regular position. It means the pair means here they refer in order to maintain the neutrality, plus minus neutrality of the material of the atoms. So there is for example NaCl is taken, and there is a missing of Na plus and Cl minus atom, so it also decreases the density of the crystal. Next one is Frankel defect. Frankel, as you see in the diagram, it is being a small displaced to interstitial voids, the combination of both vacancy and interstitial atoms. So it creates the Frankel defect, creates both vacancy, and due to the vacancy, due to the missing of an atom, the atom is placed in somewhere else inside the crystal structure, so it is an interstitial atom. And a point to be noted is there is no change in the density. The next one is line defects. As we see, the irregularities or the deviation from the ideal arrangement in the entire rows from the crystal, you can see the edge dislocation, the pattern or the rows of the lattice points are slightly shift, and there has been a irregularity in the deviation of the atoms present. The next one is interatomic bonds significantly distorted immediate vicinity of the dislocation line. So this dislocation densities, it means the line defects also affects the mechanical properties of the. The next one is edge dislocation. The edge dislocation is you can see the lines over there which follows the helical or spiral along the dislocation line. Which one is the surface defect? The surface defect are associated with the boundaries that are separate regions. These are separate regions of materials and have different crystal structure. You can see the grain boundaries in the diagram, so they can split it over. There is no regular arrangement of atoms on the surface of the crystal, and it is a two-dimensional defect. Due to this change in orientation of the atomic planes and stacking sequence of the atomic planes, so this is caused due to these discomplete misorientation of the atomic planes, and this caused due to the solidification or mechanical or the thermal treatment of the material. This also affects the mechanical properties, the electrical resistance and current. Finally, you can see the three-dimensional defect, the bulk or volume defects. The bulk or volume defects where you can see the precipitates, the fraction of a micron in size. You can see a small vacancy, a cluster of vacancies which creates a void. As we see, the precipitates is a fraction of a micron in size, since it is the size in terms of a micron, but it is the interstitial atoms maybe get precipitated on the surface of the crystal, so it obviously affects the mechanical strength of the crystal and purity of the crystal. The nature changes. Though it is in micron in size, it is also affects the complete structure of the crystal. The next one is inclusions. As we know, inclusions particles or the large precipitate particles, if there is a collection of all these kinds of interstitial atoms, particles that get penetrated or affected in the regular arrangement of atoms in the crystal, so obviously it also affects these voids, also affects the structure of the crystal. And finally, voids, this happens due to the trapped gases inside the structure, and gases which doesn't get out of the crystal due to some, if we increase the temperature at a certain level, there may be gases that generates, so it creates a void, and this also decreases the mechanical strength. Thank you.